Okay. Number 8, you probably can number 8 is, again, it's very simple. Number 8, you use same idea, but you use the, because it's a dimension 2. If I look at problem, dimension 2, so you use the Poisson formula or something. Number 8. Oh, I'm sorry. Yeah, number. That's right. Number exactly what I'm saying. It's n equal to 2. Linear wave equation n equal to 2. N equal to 2. And the initial condition h kept to 0. U epsilon is this one. This is a particular one. This one is this. This function u epsilon. I mean g epsilon is this function. E to the minus epsilon r minus 2 square r minus 1 to 3 minus r 1 less than r less than 3. So this is really like this. This is that's 1 3. So this function is, you see, if you look at how they define, when r, and here is 0. When r approaches 1 from the right-hand side, this is positive, but this is negative. So r approaching 1 from this side this is this is positive. This is also positive, but minus, right? But when r approaches 1 from the right-hand side, this is very small. So minus. And very small, so this is very large. So minus is very large. So e to the minus infinity is 0. So the graph actually looks like this. Its maxima is when r equal to 2, which is when r equal to 2 is 0, so it's really 1. So this is the graph for e to the minus epsilon. But of course, this epsilon is related to the slope of this. Okay, this epsilon, because when we take derivative of this epsilon will come out. So this epsilon will play a role in the slope. But just for each g epsilon, it is like this. Okay, so then there's a formula for the in any wave equation in n equal to 2, right? Wave equation. So you have a formula for this. I gave you the hint. Formula is on page 27, 74, 27, 74, 27. Oh, it's this formula. This formula. Uxt equal to 1/2. Again, this average. Okay, so I have this one. So this uxt, so 27, this is number 8, right? So formula 27 tells us uxt, we just follow it. X is 2 dimension, 2, okay? It's equal to 1/2 integral. Now this is 1 over, this is the surface area of a 2-dimensional ball, but 2-dimensional ball is really a disk. So surface area is simply just a circumference. So this is 2 pi r, 2 pi t, this one. And then this v xt. Note that this is on the ball. Okay, this is not on the boundary. This is different than a ball. And t g y. I think that h is 0 or something. Okay. Yeah, h is 0. H epsilon is 0. Yeah, h is 0. So I use that formula. Okay, so h is 0 is gone, I don't need it. Then I have this t dgy. So of course I need to put epsilon here. Okay. But let me dgy dot y minus x. Okay, and then here is t squared minus y minus x. Y minus x squared 1/2. And then this dy. Note that this is on the board. So this is two-dimensional integration. Two-dimensional. This is not on the surface. Okay. So then you have this integration, and the g of y. Okay, g. So u epsilon xt would be 1/2. So actually 4 pi t integral v on the board, cross board. So actually, if I want to write it better, it will be y minus x is less than or equal to t. Okay, and then tg epsilon is that one, right? Y plus t dg epsilon y dot y minus x divided by t squared minus y minus x squared 1/2 dy. Okay, and then you use that one, plug this in, and see what you can come up with this u epsilon. And it's interesting to see if when epsilon approaches 0, what happened to u epsilon? Okay, so you can look at this. What happened to u epsilon as epsilon approaches 0? Okay, what happened to this as epsilon? We'll check on this one. Okay. Or actually, on the other hand, you see, if epsilon is 0, this is really 1, 0. 0. Okay. Of course, this is discontinuous, right? This is discontinuous here, so it's not really a continuous function. I mean, not even a differentiable function. So you cannot use this rule. But it's interesting to see. Once you write this down, you have that formula, plug it in, do some estimation. Okay. So this is number 8. But you see, you already have a formula, so I just leave it there for you to compute. Okay. Now, we still have 3 more. So let me, because someone has a question about the 16, so I'm going to just do the 16. 16 is, all the rest are very straightforward because they already told you what to do. So let me look at 16. Okay, so IUT plus the plus and U equal to f of U squared U, right? And I'm going to define WXT, right? WXT to be e to the I over 4, right? 2 c dot x. So here, actually, this because it's both face c x. So c equal to c1 to Rn, right? Cn. X equal to x1 to xn. Okay? So this dot x minus c, yeah. So this both face square t. And then it's u x minus c t, right? T. So define this, and then the question is that show I satisfy the same equation. So this guy plus the Gaussian w, right? Equal to f of w square w. That's one way to show satisfy the same equation. Okay, so basically just take derivative. So alright, so I'm going to take derivative. So w sub t. So it's what? So differentiate with respect to t, right? So it's a product of 2 functions. So you product rule, right? So e to the I over 4, 2 both face dot x minus this square, right? T. So derivative of this is this guy, and then you differentiate this. So differentiate, now this doesn't have a t, so out. Only the one you have the t here, so you get minus I over 4 c square. Okay, u x minus c t plus, now you have this one, e I over 4 2 c dot x minus c square t times derivative of this, you differentiate with respect to t. Now, I had first term I have t. The first value I have t. The second value I have t. So what do? I use chain rule, right? So I differentiate the first one, the first component. I mean the first coordinate. No, the original our x is this guy. So I differentiate on the first one. So it's u. And here I have. Okay, this guy, if I write it out, is u of x minus ct, right? This is really u of x1 minus c1t, x2 minus c2t, blah, 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 and then t. So I have to use chain rule on each one of these. So it's u sub x, and just write this slowly. So it's really summation. So summation, so let me do it, write this slowly. So u x1, okay, the first one, and then differentiate with respect to t. These are only on first component. Okay, c t, and then so c1. So this c1 comes from x1 minus c1, that component. Okay, and then and then plus u, and the second one will be x2, and then x minus c t, and t c2, okay, and plus da. And then I have another one. I mean, the last one of course is uxn, x minus c t, minus. There's a minus. Minus. You're absolutely right. Minus. So minus. Okay. The minus t cn. Okay. And then I have the last one, minus u t. Now this is the very last one. So x minus c t. And there's no need for chain over here. There's only t. Equal this guy. Okay. So this is the derivative of this one. So okay. So why don't I just leave it like this? I'm going to do a lot of cancellation anyway. So then this next thing, the Prussian w, right? So provide again, I will have this kind of problem, namely I have to differentiate with respect to x1, x2. So I'm going to do it slowly. So just do one of these partial exchange with the w. Okay? So differentiate this, right? So again, product rule, right? Differentiate on this one. ei over 4 2 c, right? Dot x minus this square t. Alright, so for first one, and then I chain rule, I differentiate this. But this doesn't have x, only this guy has x. So when I differentiate on this one, I get, I'm doing it slowly, right? So I get I over 4 2 c1. This coming from this one. Okay? But this times this. And then times u. X minus ct. T. Okay? And then plus, now I have the second term, right? Use product rule. See x minus c square t. Second term is this guy. Differentiate with respect to x. So uxi, right? So uxj. But this is fine because there's nothing in front of x, so this is okay. And then so we have xj, x minus c t. So that's the first, okay? So I'm just doing this. All this just do it slowly. And then I need second derivative of this. So another one of this w. Okay. So now I differentiate again. I differentiate. This actually is constant. So I just have to derivative of these two. Okay. So